Frank Akkermans, and this is Smart Asset Management Lecture 5, Section 4, Adapting Asset Lifecycle Plans to Change, a case study at Liander. So in the previous sections we looked at everything that needs to happen when you build or construct an asset and all the maintenance plans that you have to make at the beginning. But after a maintenance program has been defined, there's this long time of asset usage. There's this time of operating and maintaining the assets, which seems just as long here as the first phase, but actually isn't, because as we've seen repeatedly, in this case again in the example of trains, this whole period is just these first few years, and then come often decades of use, including the end of life stage up here. And so this is a much longer period. And the problem with this period, because it's so long, is that changes may occur over the years that were never anticipated originally. So we already saw, and this comes also from Liander and Ruitenburg, that most of the maintenance concepts that we talk about focus really on the next coming years. And that's good, that's important. But it's a bit like with this big ocean ship that is very inflexible in the way it can move, and these icebergs ahead. In fact, Jan Braaksma mentions this quote from apparently the official investigations for the Titanic disaster, where the problem was that there was no access to the binoculars. They were in a cupboard, and the cupboard had a key, and the key was actually taken by somebody, as a result of which people couldn't look far enough ahead. And how far enough? Well, far enough to get out of the way, as it's said here. Quite meaningful. And so with this metaphor, he and his PhD, Liander and Ruitenburg, defined 5 pairs of binoculars. And we already saw those. There's the technical binocular. So you look at to what extent is it technically going to be okay, but also the economic perspective. What about the costs of ownership across the life cycle, and the compliance perspective? Are we still complying to all sorts of regulations and even social acceptance? Is it still acceptable that we use this? The commercial perspective, do we still fulfill the needs of the market? And organizationally also, do we have the knowledge really required to actually be operating this asset and the entire portfolio properly? And all these perspectives have to be weighted together. And it's not surprising then that it's really complicated to do properly. The work by Ruitenburg and Braaksma focuses then on a case at Liander, multiple cases at Liander. And Liander is one of the 3 main energy network operators, where they're located here in the green and the orange area. I see in some cases, most cases, they do both electricity and natural gas, which is important in the Netherlands. And in some cases they do one of those. And we talk about tens of thousands of kilometers of electricity and gas piping. And they're quite a visible company, because you see those vans everywhere, and the people working, and in the power stations, and even the smart meters. You see that everywhere. So what are then the asset lifecycle issues? Well, there are quite some responsibilities that they have. So there are over 3 million customers, these huge numbers of assets, a replacement value of some 10 billion euros, and those asset managers are responsible for the management of those assets. And at the same time, there are 2 main developments that make asset management plans important to update. On the one hand, there's the aging of the assets. So large parts of the networks are more than 40 years old, and that's the original time that they were expected to last. But of course, 40 years ago, how precisely could you estimate that? And what you see is that there are very wide ranges of assets that have been replaced a long time ago, and some assets that actually are already in the ground for much longer than 40 years. And there's the energy transition, with the changes in energy consumption on the one hand, especially the electric vehicles, and the changes in production, especially the solar panels and other forms of sustainable electricity, and also more and more the wind energy that's coming from the North Sea. And that means for Liander that on the one hand they have new failure modes that they have to account to. For instance, this bidirectional load, not just loading from the network but also to the network, different peaks during the day, many other issues. And also important investments that they have to make, perhaps some more local storage, perhaps more additional, perhaps certainly more capacity to facilitate all those electric vehicles and their batteries. So changes needed to be made, and at the same time there are all these different binoculars that you have to, you can only put one pair of binoculars in front of two eyes at a time, can't you? So on top of that, Liander saw, and this is where the PhD also kicks in, that they had lots of possible lifetime impact, but not really, by all means, not enough resource to tackle all of those. And in fact, because they were so diverse, those lifetime impact, it was very difficult to assess what should we do first, what is really important, what's relatively less important. And there was also not enough time available to do that. And so Richard was called in to help develop some kind of decision support tool, because in the absence of those, many decisions were made, well, not so transparent, certainly not, and often more based on emotions or on gut feel than on a really systematic analysis. And as a result of that, you get non-optimal decisions. We saw that. So what Richard Ruitenburg did together with his colleague in Liander is actually develop a staged, expert-driven method to account for those life cycle plans. And those 12 steps that he identified there also nicely led and lead to a written asset lifecycle plan to document what has been done in those stages. Basically, an important step for this is, again, how strange for engineers who like to quantify and be very precise and accurate, that it starts from multiple experts assigning values, average and rank, but those values are then on those 5 different binoculars. And when you assess those, then you can actually have a 2x2 matrix of it's a really important impact and lots of effort. So then we have to really prioritize these great. There are some quick wins where there's actually not a lot of effort, but a big impact, and definitely not spend too much time on those things that take a lot of effort and have not a little of impact. But it's still multiple experts that assign values. And here's an example, far too detailed, of course, with multiple experts assigning values, which then lead to a rank, an impact lifecycle impact number, as done by those 4 experts. But really, as Richard's pointing out, the main goal is not to assign the specific number, but actually because, well, the difference between the top 1 and 2 isn't so big, but it's really meant to facilitate a structured and transparent discussion. And that's also the way that that the participants actually look at it. And this is a broader point that was first, I think, formulated best by J. Forrester, already in his 1961 Industrial Dynamics, but also again in this very informative article from 1992. He makes a distinction between accuracy and precision. And in some languages, including Dutch, there's one word for those. But let's say if you quantify something, that doesn't mean you're very accurate in what you say. It just means it's very precise what you're saying. You can make a formal quantitative statement to for any statement you can make in descriptive English. So if you say, that's a really bad teacher, you can translate that into, on a scale of 1 to 10, that teacher gets a 3, which is different if you say it's a 5 or a 1. Then actually you're more precise what you mean, but of course, what scale do you use? How accurate is that assessment? You just make it more precise what you mean. Bad teacher, anywhere between 0 and 5. But it does make a difference if you give the rank of 2 rather than 5. So lack of accuracy, Forrester says, doesn't prevent quantifying ideas about policies. It just creates a much more explicit basis for communication, as we saw also and see in these methods. There is a common belief that you cannot quantify decision rules because you cannot be precisely accurate. And there you confuse accuracy and precision. You can precisely make an inaccurate statement. And you can quantify regardless of accuracy. But when you've then perceived through this quantification precisely what you mean, then you can ask, okay, and is this then accurate enough? Do we need to investigate this further? And that helps. So Richard Ruitenburg is an excellent company when he develops a method based on quantified assessments of really relatively inaccurate statements by experts. He then does the usual thing. Let's develop a decision tree for this, given of a certain lifetime impact, what will happen. And Bob's your uncle. But not all that easy, of course. Still a very worthwhile study of how to deal with major changes when there are multiple generations worth of asset under your responsibility.